So in this video, I'm going to run through the questions that I set for our homework. I'm not going to go through all of them, just the ones I think are difficult. So if you've got any other questions, just come and find me. I'm going to do the second part of question 3. State two variables apart from the mass of the metals. So in this experiment, you're told that you've got 3 different metals. You're going to chuck them into some acid. You're going to see which one is the most reactive. What do you need to keep the same to make this a fair test? You can't comment on the mass of the metal, so you're going to have to focus on the acid. Because the acid is a liquid, you're going to be talking about volume. Avoid using that word amount, use the word volume. So same volume of acid. You can also, because it's an acid, talk about the concentration. So that's 2 separate marking points. Same volume, same concentration. They accept same pH. They also accept same strength. And if you look at the mark scheme, it also accepts the same temperature, because temperature affects the speed of a reaction. This should all be fine. Just question 7, just watch out for fluorine, okay? It's in group 7, it is diatomic, so you have to write F2, and then you're going to go and balance. Question 10 is a word equation. That means you don't need to write any chemical formula. You're told you've got calcium, burns in air to form calcium oxide. You can't write calcium plus air. You need to write what part of air calcium is actually reacting with. Should be obvious from what you're making. Calcium oxide, calcium must be reacting with oxygen. But again, it tells you if it's burning. If it's burning, it must be reacting with oxygen. You need oxygen to burn something. The next question looks a bit weird, but it's actually quite straightforward. Effectively, you just need to be able to count. So you've got a little key at the bottom that tells you the 2 little black circles stuck together represent hydrogen molecules. And you can see before the reaction begins that you have got 1, 2, 3, 4, 5 hydrogen molecules. And after the reaction, you have got no hydrogen molecules left. So those 2 black dots have been separated. You've got no hydrogen left. So I've got 5 at the start and all 5 have reacted. If I look at the white circles, they're representing chlorine molecules, and I'm starting off with 1, 2, 3, 4, 5, 6, 7, 8 of them. After the reaction, I've still got 1, 2, 3 left. The other 5 have all reacted, so 5 hydrogen molecules react with 5 chlorine molecules. You're asked for the simplest ratio. 5:5 is simplified to 1:1. Because you have to show you're working, if you just write 1:1, you're not going to get those marks. This should all be straightforward. Safety precaution though, students go to will be gloves and goggles, but if it's a toxic gas, it's something that you can breathe in, and gloves and goggles aren't going to protect you, so you're going to need to say fume hood. You can also be overly cautious and say you would wear a gas mask, not just a face mask, would have to be a gas mask, and that will pick you up the mark as well. The next one is a balancing one. It's just slightly different from what we've seen before. If you look at the left, you have got 15 carbons in total. You need to have 15 carbons on the right. So I've got 8 carbons there and 3 there. So I've got 11 so far, and I need to then get another 4. So your temptation might be right C4, but if you look here, you've got a big 2, and the big number will be multiplied. So I would have 2 times 4. I've actually got 8 carbons there when I only want 4. So I'm going to have to change that to a 2. Now I've got 8 and 3 is 11. 2 times 2 is 4. I've got 15 carbons on the right, matches the 15 carbons I've got on the left. I'm going to apply the same approach for hydrogen. 32 on the left. I've got 18 and 6 so far, so I've got 24. I need another 8. Again, you might write H8, but then it will be 2 multiplied by 8. You've actually put in 16. So instead of writing an 8 there, you're going to write a 4. 2 times 4 is 8, and 6 is 14, and 18 is 32. So the 2 sides match, okay? You know you're just writing the formula of 1 molecule because you told you're only making 2 moles of another product, of one other product. So it's just got 1 product to fill in, so you know the carbon and the hydrogen must be bonded together. The next one, a more typical equation question. Aluminium is an element. It is not diatomic because it's a metal. Chlorine is an element. It is diatomic. It's in group 7. Forming aluminium chloride, you cannot just stick Al and Cl2 together. That's not what happens. You've got an ionic compound. You must work it out using your charges. Aluminium's in group 3. Chlorine's in group 7. The formula is AlCl3. If you write the correct equation, you get 1 mark for the left, 1 mark for the right, and if you manage to balance it correctly, you will get your 3rd mark. So with the chlorines, I'm going to make 6 on each side, 3 times 2 and 2 times 3, and then 2 aluminiums each. Something else to note, you can use the charges when you're working out the formula of your ionic compound, but you cannot have the charges featuring in your final answer on your answer line. Okay, if I had a +3 and a -1 written in the aluminium chloride formula, then I would lose that mark. Okay, so just use them for rough work. Next one, safety precaution. You can just use your gloves and goggles because it's just an acid reacting with an alkali like we would do in school. An improvement for step 4, you're using a spatula to measure out your solid. Because it's a solid, the most accurate way to measure it would be to use a mass balance and actually get the mass and know how much you're adding each time. Again, if you've got questions on any of the others, come and find me.